Good day everyone, welcome back to our discussion on the topic forces. Today we will be discussing force along rough inclined plane. Our very first question is from November 1994 and it states that a body of weight W rests on a rough inclined plane whose inclination to the horizontal is theta. The body is prevented from sliding down the plane by a force P acting parallel to the plane. If the frictional force is F, find in Newton the net force acting up the plane. And we're given the option. Now our very first step is to try and represent our question in a diagrammatic form. Now we know that from the question we have our body which is resting on the plane which will have its normal weight acting downwards at an angle to the normal, and resolving the weight of the body we get the horizontal component to be W sin theta and the vertical component to be W sin theta. Now our frictional force will be acting opposite motion, that it will be acting upwards, and our force also will be acting upwards, which is the force P. Now for the body prevented from sliding down, the forces F and P will be acting in the same direction. If the block slides down the plane, frictional force will act in the opposite direction. So therefore our net force acting up the plane will be the sum of the force going upward minus the sum of the force going downward, which will be P plus F minus W sin theta. And our correct option is E. Our next question is from November 1994 and it states that a particle of mass 10 kg is placed on a rough plane inclined at arc sin 3/5 to the horizontal. A force 80 Newton acts on the particle in a direction parallel to and up the plane. Calculate the coefficient of friction between the plane and the particle when it is just about to move up the plane. Take g to be equals to 10 meters per second square. Now our very first step is to represent our question in a diagram, and the diagram is already shown on the screen. Let us start with simplifying some of our terms. We know that our weight will be equals to 10 times 10, which is mg, so our weight will be equals to 100 newton, and our reaction rho or n will be equals to 100 cos 37, which is equal to 79.86. So when the particle is just about to move up the plane, we know that P minus in bracket 100 sin 37 plus F will be equals to 0. Rearranging, P will be equals to F plus 100 sin 37. Let this be our equation 1. Also our frictional forces will be equals to mu Newton, and we know that our Newton or our reaction will be equals to 79.86, so our frictional force will be equals to 79.86 mu. Now substituting F into equation 1, it becomes 80 is equals to 79.86 mu plus 100 sin 37, and simplifying further it becomes 80 is equal to 79.86 mu plus 60.18. Collecting like terms, that is taking our numbers to one side, it becomes 79.86 mu will be equals to 80 minus 60.18, and dividing both sides by 79.86, mu will be equals to 19.82 divided by 79.86, which is approximately 0.25. We have another question from November and it states that a particle of mass 5 kg placed on a rough plane inclined at 30 degrees to the horizontal is acted upon by a force of 40 Newton in a direction parallel to and up the plane. If the particle is just about to move up the plane, show that mu equals to root 3/5, where mu is the coefficient of friction. Now our very first step is to represent our question in a diagram. Doing so, we get the diagram as shown on our screen. Now our weight will be equals to 5 times 10, which will be equals to 50 Newton. Now resolving parallel to the plane, that is resolving all the force parallel to the plane, P minus F minus 50 sin 30 will be equals to 0, and rearranging, P will be equals to F plus 50 sin 30. This is going to be our equation 1. But friction is limiting here too, so our frictional force will be equals to mu reaction or mu n, which will be equals to mu 50 cos 30. we should rearrange it, becomes 50 cos 30 mu. Now substituting f value into equation 1 becomes p equals to f plus 50 sin 30 become 40 is equals to 50 cos 30 mu plus 50 sin 30, which simplifies to 40 times 50 times root 3 over 5 times mu plus 50 times 1 over 2. Simplifying further, it becomes 40 minus 25 will be equal to 25 root 3 mu, and dividing both sides by 25 root 3, mu will be equal to 3 divided by 5 root 3, and rationalizing by multiplying both the numerator and denominator by 5 root 3, it will give us root 3 over 5. Our next question states that a body of mass 10 kg placed on a rough inclined plane at angle 30 degrees to the horizontal slides down at a steady velocity. Find the coefficient of friction between the body and the plane, and we were given the options. Now, for a body sliding down an inclined plane with no other forces acting on the body, we know that our frictional force is equals to mu arrow, where arrow is our reaction. So dividing both sides by arrow, our coefficient of friction mu will be equals to our frictional force divided by our reaction arrow. And we know that with no other forces acting on the body, our frictional force will be equals to w sin theta, and our reaction will be equal to w cos theta. Now substituting for both f and arrow, it becomes mu will be equal to w sin theta rather divided by w cos theta, and we know that sin theta over cos theta is equals to tan theta, and our w will also cancel out. So therefore our coefficient of friction mu will be equals to tan theta. Now for our question, we were told that the angle of inclination is 30 degrees, so mu will be equals to tan 30, which is equals to 1 divided by root 3. Our next question states that a certain body with mass m kg is placed on a plane inclined at 30 degrees to the horizontal. What is the coefficient of friction of the body as it moves on the plane? Now from our previous question, we know that the coefficient of friction mu is equals to tan theta, where theta is our angle of inclination, and in this case is 30 degrees. So therefore mu will be equals to tan 30 degrees, which is equals to 0.577, and our correct option is E. Our final question states that a block of mass 10 kg is placed on an inclined plane. If the angle of inclination to the horizontal is 30 degrees, calculate Roman figure I the frictional force between the block and the plane, and Roman figure II the coefficient of friction. Now in our solution, since there is no other external force acting on the body, we know that the sum of Fs will be equal to 0, that is sum of all of our horizontal force. So therefore F will be equals to mg sin 30 degrees, which will be equals to 100 times 0.5, which is equals to 50 Newton. Now for the B part of our question, or the Roman figure II, the coefficient of friction will be equals to tan 30 degree, which will be equal to 0.577. We have some exercises for you to try your answer on at home. For more insight on the topic, you can check our Hidden Facts Further Mathematics textbooks, which you can easily get in bookshops, or if you are interested in the soft copy, you can get that at the website at the corner of the screen. Thank you.